This is Ham College, episode 121, for February 7th, 2025. Ham College is brought to you by ICOM. Combining cutting-edge technology, unmatched reliability, and user-friendly design, ICOM's amateur radios are the gold standard for ham radio enthusiasts. Good evening. Welcome to another exciting episode of Ham College. I'm Professor Thomas.
I'm Dean Martin.
And we're kind of laughing because we had a lot of problems getting the live stream started up tonight, but it's there now.
We think.
They'll let us know. So, what did we talk about on the last episode? We're studying for the technician exam, by the way.
We are, and it's probably a good thing we're studying for it. We talked about station operation, choosing an operating frequency, calling another station, test transmissions, band plans, calling frequencies, and repeater offsets, to the best of my recollection.
And this time we're going to talk about VHF, UHF operating practices, FM repeaters, simplex, reverse splits, access tones, CTCSS, DTMF, DMR operation, and resolving operational problems and Q signals. That's a lot of different things.
It is.
But we're going to talk about all of them tonight. First up, I have a little video here that was recorded back in one of the early episodes of Ham College, where you and I had a good long discussion on repeaters and the different type of repeaters and how they worked.
Hey, you mean those young guys that used to do Ham College?
Those guys.
Oh, tonight the topic is repeaters.
It is.
Yeah. So, when I got my ticket, I was anxious to get on the repeaters. I already did the research, had the repeater list already printed out. Had to type it in back then. Had typed up and printed out, and I was ready to go, waiting on my ticket and my radio to come in.
I have been waiting. Yeah, I think I listened to the repeaters and a lot of simplex for at least a month before I ever talked, because back when you and I got licensed, there was about a month wait between when you got your test taken and you passed and you received your license in the mail.
Well, it sure was.
You couldn't transmit until you actually had that paper in hand.
I remember the day my ticket came in the mail. I already had my radio, just like you got yours before yours came in. It was up. I lived in an apartment. And I remember walking down to the mailbox, and that ticket was in there, and I just about ran all the way back to get the radio when that ticket was in. And I got the radio, and I was scared to death to talk on it at that point. So
I think that's kind of a common thing.
Yeah.
You know, so we're going to recommend, listen first. If we're going to talk about repeaters, I guess the first thing we really ought to talk about is not a repeater, but simplex.
Yeah.
That means if you and I are going to sit here and talk back and forth, we only need one frequency to do that on.
Yeah, absolutely.
And especially if we're close enough to each other that we can do it. As a matter of fact, we don't even need a frequency right now. We can
just audio frequency.
Yeah, but I mean, so we'll only need one frequency, and typically that would be what we'd call simplex. Here's a typical simplex frequency right here. This is, what is that frequency famous for, Tom?
That's the national calling frequency for 2 meters.
It is. So, let's see. I guess you'll be the guy with the beard there.
Yeah, that'll work.
And I'll be the other guy
with the bow tie. Where's your bow tie?
I left it. So if I'm going to talk to Tommy, key up my radio, and I'm sending out a signal there on 146.52 megahertz. When I'm through, I let off that push to talk button, and then Tommy can press his, and bam, he's talking on the same frequency.
Just like magic.
Just like magic. And now I can hear him. So we're both using the same frequency, so only one of us can talk there at a time, and then we've got to wait for the other one to unkey before he would be able to hear us. So that's what we mean when we say simplex. It's simple communication, just using a single frequency. One direction at a time. Now, Beyond that, there's another mode, sort of like simplex. It only involves the two radios that are being used there, and that's called full duplex. And what full duplex is, you've got two different frequencies. You can see when Tommy's talking to me there, he's on 146.52. I'm talking back to him on a UHF frequency. I'm on 445 megahertz there. And this is sort of like a telephone. We can both hear and talk at the same time.
Yeah, yeah, you sure can. If you have a dual band, dual watch radio, that can monitor at the same time it's transmitted. So that's a little bit of a hardware specific thing, but yep.
Yeah, and here we're showing doing it with two different bands because that would be the easiest way. You don't see a lot of full duplex communication, but it is possible, and it's just another mode that you could use.
Yeah, I remember we tried that when I first got my ticket. Just kind of playing around.
It's pretty cool in a way because if somebody gets long-winded, you can tell them, hey, you're getting long-winded. You can break in on them, but if you're on simplex, that's not possible. A guy could sit there and,
yeah,
you really keep talking for a long time. But simplex only uses half the bandwidth because it's only the one frequency there. So
yeah, if you're in a congested area, you want to be careful with that.
Yeah. Now, sometimes we might be in a situation, say, where I'm here and Tommy is way over there, and as a matter of fact, he's so far away, our radios can't hear each other. And in a case like that, we still want to talk. What do we do, Tommy?
Yeah, we're going to go to a repeater.
And here's a repeater right here. You're talking to me on 146.34, but my radios, I've got it tuned to 146.94 because I'm on the 9.4 repeater. You would think, well, I wouldn't hear you because you're off on another frequency.
You would think.
But what's going on there is that repeater is a receiver and a transmitter. So the repeater is sitting there listening all the time on 146.34 megahertz. And whatever it hears, it rebroadcasts out here on 146.94 in this case.
Right.
So while you're talking, I'm listening on another frequency that's 600 kilohertz above where you are in this case. Doesn't have to be, and we'll talk more about that in a minute. When you're through talking, then I can talk back to you, and guess what? I'm going to do it on the same frequency you were using, 146.34, because the repeater is still sitting there. It's always listening to that frequency, and it's always transmitting out on what is typically known as a repeater frequency, 146.94, or whatever frequency you're using. When you say join me on the 146.94 repeater, you're talking about the one you're listening to. Yeah,
the output frequency of the repeater.
Right. When you go to talk, the repeater is going to pick you up. It's listening on a different frequency, and it's going to rebroadcast you on that particular frequency.
Right. It's that's a good diagram too, because I remember right after I got my ticket, it was a little bit unusual for me to the comprehension of how that works, how it actually listened on one frequency. When you transmit, you were transmitting on another one on the same radio, set up there, and it's really without looking at the frequency, you really don't know.
Yeah. So what is our benefit here from using a repeater? Why would we even want to do that?
Well, typically a repeater is going to be, the antenna is going to be up on a tall building or on a tower or on a mountain, someplace that's got a lot greater coverage. So you can get one that's in the middle, or actually the coverage area is great enough that we can both get into it and hear from it.
So well, if I'm sitting here on a handy-talkie and you may not can hear it directly, that 1,000-foot tower sitting over there can hear it just fine and transmit out a signal strong enough that you can pick it up where you are.
Absolutely.
So you take the little radio that, I don't know, maybe you could talk, 4 or 5 miles with it?
Something like that,
and then,
depending on the conditions.
Then, depending on what repeater you're talking on, maybe now you can talk 50 miles.
Oh, because usually on the right repeater.
Yep. So the repeater is really doing the heavy lifting there, and you're just, you're kind of piggybacking on it.
Yeah. So what's the downside of using the repeater?
The downside of using the repeater is, it's using two frequencies because it's listening on one frequency and it's transmitting on another. more people are going to be able to hear you. That's not necessarily a downside, but
it's not a downside, but it's something to be aware of.
Yeah. And the repeaters are shared. You know, anybody else who wants to use that repeater is going to have to wait their turn till the current conversation.
And that's what I was thinking of when I asked what was the downside. It's a shared system, and so you don't want to just hog it. You know, hog all the time on it. So you got to be courteous about it.
Yeah. Leave room for other people to talk too. Don't just take it up for your exclusive use. Although there are closed repeaters out there that were put up with the intention that only a small group of people is going to be on this one, and you got to be on our club or don't talk on it. Well, most repeaters are not that way.
Right.
There's only a few that way, and you can ask around locally and find out which ones are, which one everybody's welcome on and which ones maybe not. You know, they have a club.
I believe in our area, I don't know of any that are closed.
No, I think everything here is, wide open to anybody who wants to use it. And it's that way in most of the U.S. Another good thing about repeaters is I can talk here and a lot of people can hear me all at the same time, which that could happen on simplex, but the repeater's going to have much better coverage area than I've got, just sitting here at home. And the repeaters don't only benefit a handheld radio. I mean, if you've got a base radio, your antennas, you may have a tall tower and you may not, but you can always use a repeater from your base station and get the advantage of having a strong signal.
Yeah, we've spent many an evening having a nice rag chew session with a bunch of us from several counties to the north and some people right here around, and that we couldn't have normally talk to directly like that with simplex.
Now, I've got a repeater here in my shack, and I know you do too, that you use all the time.
Yeah.
But it's not like the repeater we were talking about a moment ago. What is it?
Yeah, you talking about the crossband repeater?
Yeah.
That's where the radio monitors one or the other, actually monitors both bands, and whatever band receives a signal, it's going to actually transmit that audio out on the other band.
So in the case here, I've got my base station set up with 430 megahertz on say the UHF band and 146.40 on the VHF band. If it hears anybody talking on UHF, it's going to rebroadcast out the same thing on the VHF frequency there, and vice versa. So either one of us can talk. You can see in this case, I'm always staying on 430 megahertz there, which I'm not sure if that's a good frequency to be doing that on or not. I don't ever recall using that one.
Yeah, I'm thinking maybe not, but but it's good for demonstration purposes. Yeah.
So I just stay on that one frequency. Oops, went back too far. I just stay on that one frequency there on the UHF band, and you're over on the VHF band just using one frequency, and it's crossband because it picks it up on one band, transmits it out on the other. So why would you want to do it that way? What's the advantage over doing that as opposed to having that other repeater where both frequencies were like in the VHF band?
Well, it basically you get a lot of the same advantages as a regular repeater, because most of the time that's running on a base rig somewhere that's got a decent antenna, and maybe you're walking around with the handy talkie, in the shop, in your at the house or something, and your radio's out in your ham shack, and you could still be just as accessible and talk to the same people.
I guess what I was trying to say is the difference between a repeater and a crossband repeater. A repeater is generally what's out there for public consumption. I mean, where it's receiving on, say, on the 2 meter band, and it rebroadcasts it out or retransmits it, repeats it on another frequency on the VHF band. When we use crossband, it's using two different bands to do that. And the advantage of a regular repeater is that, hey, if they're on VHF, you only need a VHF radio.
Yeah,
if they're on UHF, you only need a UHF. With the crossband, you'd have to have a dual band radio, one that can, transmit on VHF and UHF, and hear and transmit both on both those frequencies. But the advantage is when you start trying to put a transmitter and a receiver both on the air at the same time, it takes a little bit of special combining, say, to put both of those on one antenna without them interfering with each other.
Right.
So you have to use duplexers at a regular repeater site, which are generally tall cans, yay big around, maybe about this tall, and they're tuned. There's a tuning stubs on them, and it takes several of those to make filters so that the transmit frequency does not interfere with the receive frequency. Because if you're transmitting and receiving on the same frequency, it doesn't work. I mean,
right.
It's feedback. It's like taking a microphone and putting it in front of a speaker, more or less. So we have to use two different frequencies for that, and the duplexers are able to separate those two so they can run over a single coax out to a single antenna. With the crossband, it doesn't take all of that. You can use a duplexer for that is much smaller. I mean, fits in the palm of your hand, and it'll combine VHF and UHF. Where if we were trying to do two VHF signals or two UHF signals, it's going to take a lot more filtering because those frequencies are so much closer together.
Right.
So, crossband, that's a good solution, and it's one we use here, like you say, taking your handy-talkie, and I want to talk further with it, so I just crossband repeat through my bass rig.
Yeah, it's handy. A lot of radios have that built in now.
And then there's one other type of, well, I guess you would say repeater, and that's, say, a linked repeater. And these are common now. They weren't very common back when you and I got licensed back in the 90s.
No, we had a few around here, but it wasn't mainly activated during storms.
Yeah, but now there's a lot more ways to link repeaters, and what that is looking at the picture there, Tommy is actually talking on one repeater somewhere, and I'm talking on another one somewhere else, and we don't have to know what frequency each other's on, really. The two repeaters are connected to each other, and they handle all of that, and they can be connected together over radios, over wire, or over an internet link like Echolink or D-Star or IRLP or System Fusion.
Yeah.
Or there's probably some more in there I didn't even think of. But so in the old days, if we had a linked repeater, then that meant one repeater here and one over there, and they're talking back and forth to each other with radios so that they can each share each other's coverage area. But now, with the internet, a lot of these repeaters are linked to each other, over the internet.
Yeah.
So it's not unusual that, we could go to a radio here, get on one of the repeaters and talk to, Peter down in Australia or somewhere, anywhere in the world. 20 years ago, that would have been pretty much unheard of on a repeater. Oh yeah, we've done it a lot. Yeah. So a linked repeater, or repeaters, that would be more than one. That's another way a repeater could be used. And then there's one other type of repeater too that...
You mean there's more?
Yeah, and let me let you guess what that is. Oh, you're reading, I saw you.
I saw it pop up there. And I actually forgot about that one.
I figured you would.
A simplex repeater.
Yep.
And that can be really annoying if you catch one on the air.
Yeah, it can also.
It can mess with your mind.
It can be kind of spooky. Yeah, that's happened to me before. And what that is you're using one frequency for everything, transmit and receive. So the repeater is actually just a radio that's sitting there, and it's listening on a particular frequency, and the whole time it's listening, it's recording. When it gets through with that recording, when it senses that you let off the push-to-talk button, then it turns around and it plays back and transmit out whatever it just heard. So if you sit there and you talk for 2 minutes solid, it's recording you for 2 minutes. When you let off, it plays it back.
Yeah. They had a guy, where you remember the guy, there was one on the simplex channel that we used, and every now and then you'd hear that thing.
Yep. Years ago there was one, and you'd come on, you'd say your ID, and we didn't know the thing was there. And then all of a sudden you'd hear yourself say your ID back to you. At first I thought somebody was messing with me. They were recording me and playing it back, and then I realized, no, it's a simplex repeater. What is the one redeeming point of them? Why would you even consider one of those?
You can build that fairly easily yourself, and you can run it off of one single band radio.
Yep.
One frequency, one real simple, inexpensive radio.
Yep. So it doesn't take a lot to do it. It could be set up pretty quick if you had the stuff to do it with.
I think you could probably build that pretty easily.
You could. You could today, especially with computers. Makes it a lot easier.
I sense a Raspberry Pi project, maybe.
Yeah, I hadn't even thought about that. But yeah, that should be easy enough to do.
Should be real easy.
As long as you can determine that it's keyed up. Which, yeah, I could see you doing that.
I have to look into that.
Yep. Well, so there's a little lesson on repeaters there. There's a lot more to know. We're going to be talking a little more about some of the various subjects tonight as we go through the question pool here. But right now, why don't we take a break and get a message from ICOM, our sponsor here, and then come back and let's get into the questions and answers.
Right.
Combining cutting-edge technology, unmatched reliability, and user-friendly design, ICOM's amateur radios are the gold standard for ham radio enthusiasts. Whether you're chasing DX, experimenting with digital modes, or leading a local net, ICOM radios deliver crystal clear performance and seamless connectivity. With a legacy of innovation and commitment to quality, ICOM continues to set the benchmark for amateur radio excellence, making them the trusted choice for operators worldwide. Introducing ICOM's IC7760, the pinnacle of base station excellence for amateur radio enthusiasts. Designed to deliver unmatched performance, the IC7760 features state-of-the-art technology, exceptional RF clarity, and an intuitive interface, all housed in a sleek and durable design. The base station features a separate remote control head and RF deck, providing excellent flexibility for installation. Place the RF deck closer to the antenna feed point, freeing up space on your desk. You can also connect the control head to the RF deck through your home network, enabling remote operation from anywhere in your home without need for a PC. Pair the IC7760 with a powerful ICPW2 linear amplifier and take your contesting experience to the next level. The ICPW2 seamlessly integrates with the IC7760, delivering a massive power boost and enabling enhanced long-distance communications with DPD, digital pre-distortion, and a built-in 2x6 automatic antenna selector for SO2R single operator 2 radios. Together, they define what's possible in amateur radio, setting a new standard for global connectivity and reliability. For more information about all of ICOM's great amateur radios, visit ICOMAmerica.com/amateur.
What do you say we give away something?
Well, okay. How about this great looking t-shirt here? Maybe some other swag, maybe. Who knows?
Yeah.
Nice ICOM Ham Crew t-shirt. You look just as good when you leave the ham fest as you do when you got there.
Yeah, something like that.
Something like that.
Yeah. If you wanted something like that, well, there's a way that you could get one.
That's really easy, actually.
What do?
Send an email to hamcollege at AmateurLogic.TV. The address is right there on the screen for your convenience.
And
what do you think they ought to put in there, though?
Well, they could put a little message to us. They don't have to. All they really need, email address and a name.
Yeah?
That's all we really need. And that's more or less what we got this time around in the drawing.
Okay. Who won this time?
This time around, it was Lisa W0OL.
Cool.
Congratulations.
Lisa.
ICOM will be in touch shortly and get the details and get it shipped out to you.
Awesome.
So if you want to win, and face it, why wouldn't you want to look as good leaving the Hamfest as you did when you got there?
I know, right?
Ham College at AmateurLogic.TV. Get your entry in today if you're watching the show here.
Yeah, and we've said it before. Might as well say it again. But we don't keep your email addresses. Nobody gets them. Only the one that wins goes to ICOM, and the rest of the queue gets cleared out every month. So we don't even keep them ourselves.
Nope. So let's get on into the questions for tonight. What do you say? I think we'll probably talk about repeaters a little bit. Just a hunch.
I got a funny feeling you could be right. How is a VHF-UHF transceiver's reverse function used? A, to reduce power output.
B, to increase power output.
C, to listen on a repeater's input frequency.
Or D, to listen on a repeater's output frequency.
Well, I just so happen to know this one because I have used a reverse function button before.
Yeah.
It's not to reduce power output, and it's not to increase the power output. It's more related to the repeater frequency. And normally, you listen to the repeater. What? Did I say something wrong?
Well, I thought you were asking me the question. If you want to give me the answer too, you know.
I got pretty. Okay, let's start over.
Oh, we'll just let it go. How is a VHF-UHF transceiver's reverse function used? I was wondering for a minute what was happening. Yeah.
I was on a roll, man. I shouldn't have had that cup of coffee this afternoon.
Yeah, I should have asked you. It doesn't reduce the power. Doesn't increase the power, so it's got to be C or D. If you use the reverse button on your radio, you're going to be listening to a repeater's input frequency, provided that you actually have your transceiver tuned to a repeater frequency.
It's always a catch.
Yep, they didn't say that, but I'm thinking that's what they mean. I'm going to say C like everybody else over in the chat room.
Well, I think you're probably right. And they are as well.
Yep. They're saying C, except Chip says I'll have what they're drinking. So
I had too much coffee, clearly, because I didn't want to wait for the answer. I was just ready to go ahead and spit it out.
Oh, man, you was ready to get to the end of it, huh? All right, I got one for you. You can answer this one.
Okay.
All right. What term describes the use of a subaudible tone transmitted along with normal voice audio to open the squelch of a repeater? A, carrier squelch.
B, tone burst.
D, DTMF.
Or D, CTCSS. What term describes the use of subaudible tone transmitted along with normal voice audio to open the squelch of a receiver? It's not going to be it's not B, tone burst. Don't they use that in Europe? Like a tone burst at the first?
You could use it here if you wanted to, I guess.
DTMF is more like your touch tones if you're going to type in some kind of a code or something to remote control something. But D, CTCSS, is going to be the answer, and I'm trying to remember what that stands for. I don't remember what CTCSS stands for, but I do know that's the answer.
Continuous tone something squelch system.
Somebody in the chat room is going to correct us.
Yeah. So we got some D's and a C in there.
I'm going with D, 100%.
I'll agree with you. And it is.
Continuous tone coded squelch system. There you
That's
go.
it.
Thanks, Colin in VK.
Yeah. So apparently they use it down there too. Of course.
I
Why
think pretty
wouldn't
much everybody does.
These days, when we got licensed, they weren't used as much.
No,
Subaudable
pretty much
tones.
everybody's got one now.
Pretty much, yeah. Yeah, everybody's using it now, and you kind of got to keep just interference off,
Yep. Which of the following describes a linked repeater network? A network of repeaters in which signals received by one repeater are transmitted by all the repeaters in the network.
A single repeater with more than one receiver.
C, multiple repeaters with the same control operator.
Or D, a system of repeaters linked by APRS. Which of the following describes a linked repeater network? Well, it's not D. It's not used for linking repeaters. C, multiple repeaters with the same control operator. Nah. B, a single repeater with more than one receiver. Yeah, trick answer there, but that's not it. I think it's a network of repeaters in which signals received by one repeater are transmitted by all the repeaters in the network.
I would concur with that. I think we got a little bit of that going on around here now.
Yeah, they're saying A over in the chat room. Which of the following could be the reason you are unable to access a repeater whose output you can hear? A, improper transceiver offset.
B, you're using the wrong CTCSS tone.
C, you're using the wrong DCS code.
Or D, all these choices are correct. Well, if you're using the wrong transceiver offset, that means you would not be transmitting on the repeater's input frequency, so that could be it. If you're using the wrong CTCSS tone, well, I would think that would be it too, because you wouldn't open the squelch for the repeater to get your signal in there so it could be retransmitted out. Using the wrong DCS code, which I think that's what I was thinking about earlier, that they use in Europe a lot. The codes at the first you transmit. Or it could be D, all these choices are correct, which I'm going with that one because I could see all three, A, B, or C, being an issue with getting into the repeater.
Yep. Digitally controlled squelch. That's DCS. Yeah, I'm going to agree with you. Chat room does.
Thanks, chat room.
It is D.
Oh, yeah.
Oh, and everybody in the chat room, too.
Yeah.
Yeah, they brought it up in there.
They just knocked the laptop off. What would cause your FM transmission audio to be distorted on voice peaks? Your repeater offset is inverted.
B, you need to talk louder.
C, you're talking too loudly.
Or D, your transmit power is too high. What would cause your FM transmission audio to be distorted on voice peaks? Your repeater offset is inverted. A, nah. B, you need to talk louder. I think it's pretty obvious to most folks that that's not the answer.
That could be the opposite of the answer.
D, your transmit power is too high. Really won't matter on FM. C, you are talking too loudly. I think that could be it. Chat room, C's. We did get a D in there. I'm sticking with C.
I concur. Here we go.
There. What type of signal uses pairs of audio tones? A, DTMF.
B, CTCSS.
C, GPRS.
Or D, D-star. What type of signal uses pairs of audio tones? Well, it's not D-Star. It's not GPRS. It's not CTCSS. We just said that's a subaudible tone. But DTMF is dual tone something something. I'm going with DTMF.
Okay, even though you don't know what something something is. It's just a little bit of something something. Is that what you
It's
say?
a little something something.
Yeah.
If I'd have studied, I'd have looked up those are they acronyms? I don't know, but I didn't study. Don't do like me and you study so you know. But I don't remember what it stands for. Dual tone. I don't remember. Do you?
No, dual tone multiple frequency. Yeah, I'll agree with you. It's A.
Dual tone multi-frequency.
Yep.
How can you join a digital repeaters talk group? A. Register your radio with the local FCC office.
B. Join the Repeater Owners Club.
C. Program your radio with the group's ID or code.
Or D. Sign your call after the courtesy tone. How can you join a digital repeaters talk group? A. Register your radio with the local FCC office. Most places don't have a local FCC office, and if they did, they don't need you to register your radio.
They don't want to see your radio.
No. B. Join the Repeater Owners Club. Well, I guess you could do that, but it's still not going to make your radio work. C. Programming your radio to the group's ID or code. Or D. Sign your call after the courtesy tone.
The C seems plausible.
Yeah, the D doesn't.
No,
So,
D definitely doesn't.
C. Yeah, I'm going to say it's C. The chat room, they're all saying it's C. And, yeah, some of those are really bad answers.
Yeah. Like
That one's not, though.
That one should be pretty obvious to most people.
Yep. What do you say we take a quick break so I can load up another set of questions?
Around the 15th of each month, it's Amateur Radio's original and longest-running video podcast, AmateurLogic.TV, with hosts George Thomas, Tommy Martin, Emil Diodene, and Mike Morneau.
Roughly, here's what I have. The bottom trace here is ground.
While the elements will jiggle some, they're actually not too bad. It's light.
After putting it together, I decided to test everything, so I ran in 12 volts, and I'm measuring the output here.
No, it's not too windy right now, Jim. It was yesterday.
We're in the antenna switching matrix. Any one of our 6 broadcast transmitters could be connected to any of the 22 antennas.
I personally am so thrilled that George got the special award. Well deserved, my friend. That's really cool.
What about the Super Bowl, Emil? Did you go to the Super Bowl, or were you at home operating that night?
Tuning my amplifier, and I lost power in the shack, and went outside. The house lost power. The whole neighborhood went out for about 30 minutes. I don't know what happened.
Wow. That explains a lot. Now we can take this and put it over inside our box. It's flush to the bottom. If we were to rotate, we can see that thing goes all the way through. So we'll have a hole in the bottom.
What ammunition do you use in there?
Actually, you can use black powder. You can use WD-40. You can use, anything combustible. You just have to use the right quantity, and we assume no responsibility for mishaps.
Here's what it looks like after I've got them all soldered together and heat shrinked up. Okay, let's give it a try and see how it worked out. So there you have it, the hula loop. No, you can't null out the dogs barking.
I have 2 thin film solar cells to run this. Looks like a little mini weather satellite, actually. And I'm using guitar string for the antennas.
I particularly like that last one there, $29.99. You can get a 50-foot garden hose extension cord combo.
Do not get cord wet.
Now, most of these J-poles are built with metal elements or tubing, The reason I chose wire for this one is the length of this particular one, so I wanted to hang it from the tree so I can hoist it up there.
Yeah.
Go fishing.
Well, we couldn't find the reel.
Yeah.
Is that what that is?
All right, Tommy, sing the theme song here.
Every time. I still haven't sang it.
Yep.
Whenever we do the last show, I'm going to bust out in song.
I can hear it now. Which of the following applies when two stations transmitting on the same frequency interfere with each other? A, the stations should negotiate continued use of the frequency.
B, both stations should choose another frequency to avoid conflict.
C, interference is inevitable, so no action is required.
Or D, use subaudible tones so both stations can share the frequency. Well, D doesn't really work like that. C, interference is inevitable, so no action is required. That's not really being a good citizen either.
No.
I mean, it is inevitable eventually, but everybody needs to be good citizens, kind of be respectful. B, both stations should choose another frequency to avoid conflict. Well,
That would work.
it would work, but it seems a little bit drastic. Only one maybe should. But I think the answer is going to be A. Stations should negotiate continued use of the frequency. So be a good guy to talk to or offer to find another frequency or whatever.
Yeah.
But anyway, be courteous. Main thing.
Peaceful negotiations.
Yeah.
Yeah. A, and that's what everyone in the chat room said as well.
Why are simplex channels designated in the VHF-UHF band plans? A, so stations within range of each other can communicate without tying up a repeater.
B, for contest operation.
C, for working DX only.
Or D, so stations with simple transmitters can access a repeater without automated offset. Why are simplex channels designated in the VHF-UHF band plan? Well, that last one, D, so stations with simple transmitters can access a repeater without automated offset. I'm not even sure what that means. Maybe I know what they're trying to say, but that's not the answer. C, for working DX only. No, you can work DX on a repeater.
Done it.
Yep, me too. C, for contest operation. It'd be nice for contest. Working a contest on a repeater doesn't seem like, doesn't really seem like a contest.
Mm-mm.
A, so stations within range of each other can communicate without tying up a repeater. To me, that sounds like the most excellent answer.
Most excellent.
That's what everyone in the chat room's saying.
Yeah, that's what we do.
Yeah, because, we live close enough together. We got a good signal path between us. Why would we tie up a repeater?
Right.
That would take 3 radios to pull off, where we can do it with 2. That's just how good we are.
Yeah, that gives a knuckle now.
No. If you're close enough, you can hear each other. That's the best way to go, unless you're wanting to draw a crowd and get some more people in the conversation.
Which is perfectly legit.
Yeah, that's okay too. Yep. Which Q signal indicates that you are receiving interference from other stations? A, QRM.
B, QRN.
C, QTH.
Or D, QSB. And I should be ashamed of myself, but I'm not the best on some of these Q signals. I'm thinking it's A, QRM.
QRM. So you're just going to ignore all the others just right off the bat.
I don't even know how to reason those out. I don't know. I told you I don't remember what most of them are.
What's QTH?
That's my location. I know that one.
Yep.
I know QSY, but it's not up there.
Yep. QSB,
Signal's fading.
effects of ionosphere instability. Okay.
Okay.
Yeah. I've heard fading.
You know, I used to keep a sheet by my station that had all that on, but I don't even know what happened to the sheet anymore. It may still be there.
Same here. It may still be there. I haven't looked at it in a long time. There's only a handful of those that I ever really use.
Yeah, same.
QRN. That's interference, but it's natural interference.
Yeah, it's like electrical noise or something like that. I think it's QRM.
QRM, man-made interference. I agree with you. Yeah.
But you probably should know some of them for your test, clearly.
Well, definitely, yeah. Particularly that QRM and QRN, man-made or natural interference. QTH, I think that comes up too.
Yeah, that's your location.
Yep.
Which Q signal indicates that you're changing frequencies? A, QRU.
B, QSY.
C, QSL.
Or D, QRZ. Z.
Okay, maybe I do know more than I thought.
Which Q signal indicates that you are changing frequency? Well, QRZ means, what's your call sign?
Yeah, who's calling?
C, QSL means...
It's an acknowledgement.
Yeah, affirmative. Yeah, acknowledgement. QRU. A.
I don't know what QRU is.
Yeah, me neither. B, QSY. That means I'm changing frequency, and that's one that you definitely want to know, because you'll hear people just as soon as you get on the air saying, I'm going to QSY to a certain frequency or a certain repeater. And it would be handy to know, oh, he's changing frequency, so I can change frequency.
Those bottom three on that list are probably the three that I use most of all.
Yep. QRU, got any traffic for me? Thanks. Tom knows. He's got that sheet, man.
That's where my sheet went.
No, Tom knows this stuff. I never use that one. But then again, I don't participate in nets.
Not too often.
Not very often.
I've only ever been on a net that actually really passed traffic a few times. It doesn't happen all that often.
It happens a good bit on the some of the section phone nets.
Yeah.
Although I'm not a faithful participant, I do try to participate often enough to keep my name on the roll.
Yeah, well, I'm a roll dropout.
Well, you'd have to have a real antenna.
I don't have one for that band.
No.
I'm going to do something about that this summer.
QSY. Yeah,
QSL.
I need to get you over here with your fishing rod again, like I mentioned earlier, and get you to help me string a new line. I've been looking at it.
I have that fishing rod. I'm ready to go fishing anytime.
Okay. What is the purpose of the color code used on DMR repeater systems? A, must match the repeater color code for access.
B, defines the frequency pair to use.
C, identifies the codec used.
Or D, defines the minimum signal level required for access. I'm not a big DMR guy, although I did buy a little cheap DMR radio one time just to kind of see what it's about. So it's D, defines the minimum signal level required. That is not it. I know that's for sure. C, defines the codec used. That's not it either. B, defines a frequency pair. Well, just so happens that that's not it either. So it's going to be A. You must match the repeater color code for access. And I'm not exactly sure what it is. I guess it's some kind of code. Remember the earlier question about the get the access code for your repeater?
Mm-hmm.
I guess that's basically similar thing. So I'm going with A. Must match the repeater color code for access.
Yeah, I only know where the color code, from my experience, applies with DMR radios.
Well, this is just for DMR.
Yeah. And I think that may be, I'll not say, because I'm not positive, but I think.
But you can't get a buzzer for an opinion.
Okay. Well, that's right, because that is not my question.
It's not my problem. Yeah.
Yeah. Let's go ahead and see if you're right before I say anything.
I'm right.
There you go.
Well, I'm glad I am, because I'd look pretty dumb after saying that if it wasn't.
Palm says it was used by DMR to allow business users to segregate users into like maintenance guys or security or other groups.
Okay.
We got one more question.
What? That's it?
I think that's it, yeah.
What is the purpose of a squelch function? A, to reduce a CW transmitter's key clicks.
B, mute the receiver audio when a signal is not present.
C, eliminate parasitic oscillation in an RF amplifier.
Or D, reduce interference from impulse noise. What is the purpose of a squelch function? A, to reduce CW transmitter key clicks. No, I don't think it would help with that. D, reduce interference from impulse noise. No, you would use a noise blanker to help with that. C, eliminate parasitic oscillations in an RF amplifier. No. Squelch is used in a receiver. So it'll be B, mute the receiver audio when a signal is not present. That's my answer. B, mute the receiver's audio when a signal is not present. You know, if you really want to play a nasty trick on somebody, I mean, a horrible trick. For Christmas, buy their kids a set of cheap walkie-talkies that don't have a squelch.
Oh.
Yeah.
Do they even make those anymore?
They might. They were making them a few years ago because somebody gave my kids a set of those. That was a few years ago.
That's been a lot of years ago, but your kids are grown.
Yeah. But they may still make them. And they're sitting there.
Like the little Channel 14?
Yeah.
Space Patrol walkie-talkies?
Yeah, the cheapest ones you could buy did not have a squelch. So they're running around just screaming with noise all the time.
I had a pair like that when I was a kid. My first set had like that.
Yep.
Turn them on, it was nothing but noise. I was going to say white noise, but it was worse than that. It's just plain old blasting noise.
So if you're going to use an FM radio, you are definitely going to want a squelch, like 2 meters, 440. You know, the frequencies that we use FM on commonly, you'll get good use out of that squelch. Now, a lot of the newer handy talkies won't have an adjustable squelch knob on it. That'll be set down inside the menu somewhere. But it's in there. And you would not like that radio at all if you had to sit there and listen to that continuous noise, static all the time. You only need to hear it when somebody's talking.
I'm wondering if they do make those anymore. I don't know if they make like Channel 14 radios.
Oh yeah, I'm sure they do.
You think so?
Oh yeah.
Because all I ever have seen is like those FRS little cheap little things. You get like $30 for a pair.
Well, they could make them without squelches too if they wanted to.
Yeah, they don't. I haven't seen one. I have a pair of those.
Yeah. Well, maybe you didn't get that option.
Maybe I got the deluxe one.
Yep. That's it for tonight. So what if you didn't happen to have a Hawkins Middle School t-shirt?
And you didn't get your entry in? Which you should get your entry in for these, to get the ICOM swag shirt.
Yep.
Really great shirt. But if you didn't do it, Where could you get a shirt? Is that what you were going to ask?
There are other places you can get shirts, aren't there?
There are a few other places. There's one main one, though. It's shop.spreadshirt.com/AmateurLogic. That's where all the cool kids get their shirts if they don't win the icon one.
That would be a good place to get one.
The best place.
The best looking ones anyway.
Heck yeah.
Or at least the most popular logos. We only have these shows once a month, and we'll be back around the middle of March with the next episode of Ham College. And no, that'll be at the end of March.
We might be back at the middle of February for Amateur Logic.
Sometime around then, yes. So that means only twice a month can you join here and enjoy all this social activity. In between times, what if you wanted to visit with some of your ham radio buddies and you couldn't communicate with them?
Don't be antisocial. Go to the social media sites and go to facebook.com/groups/Ham College.
Or you could follow at Ham College on X or Twitter.
And if you're not really too into that, there's basically like a mail list. It's groups.io/G/AmateurLogic.
And what if you needed show notes? What if you remember that we talked about a certain subject, but you just don't remember what episode it was? You need to go back and look up something.
Well, I know this guy that knows a guy that actually does those. AmateurLogic.TV /wiki.
Well, that's going to do it for another episode of Ham College. We want to remind you, if you're not a ham, then this show was designed for you because we're studying the amateur radio technician pool currently. This is the entry-level exam you need to pass to get into ham radio, get your entry-level license. There's a number of resources you can use. One is Ham College, and we'll go through, and pretty much what you saw tonight is what we do. But there are books as well that are very helpful for studying. One is from WB6NOA, our friend Gordo.
Yeah.
He does an excellent amateur radio study guide, so you'll want to check out his books. They're available through ARRL. Also, ARRL.org has their own books as well. The Tech Q&A, which is a small guide here, basically question and answers and brief descriptions on some of the questions. They'll give you a little bit of information on others. Not very much. But then they also have this thicker book here, Ham Radio License Manual, 5th edition. This one has much more detail in it. Gives you a lot of the background and theory on a lot of ham radio topics, your band plans, antenna projects, one thing or another, in addition with the question and answers. Any of those 3 books are excellent resources for studying for your technician exam. You can also take tests online at hamstudy.org and a number of other places. You do a little studying and go take practice exams online and see how you do. Now, we don't recommend that as your only method of study. That's just one more tool to get your license. So with that, I think anything else you need to expound upon tonight, Dean Martin?
No, I think you covered most of it.
Okay.
Again, if you want to get in for the drawing,
Ham
email
College
at hamcollege@amateurlogic.tv.
Mm-hmm. Thanks for being in here, everyone. 7-3, and we'll see you on the next one.
7-3, everybody.